The gravity of the time is such that every new avenue of peace, no matter how dimly discernible, should be explored. Never before in history has so much hope for so many people been gathered together in a single organization. You will provide a great share of the wisdom, of the courage, and the faith which can bring to this world lasting peace for all nations and happiness and well-being for all men.
So we are here today with Adam Stein, who's the Director of Nuclear Energy Innovation at the Breakthrough Institute. Adam, welcome to Titans of Nuclear.
Thank you very much.
Yeah, I reached out when I saw your latest article, which I thought was like, oh man, just so on point and just so happy someone is out there like giving this kind of analysis, which I feel has gone so uncovered for so long. So, but before we get there, I'd just love to learn about you. So why don't you kick us back to how you got started? Like, where'd you grow up?
In Pittsburgh, Pennsylvania, where I still am, actually.
Oh, you're still in Pittsburgh? And have you lived in other places throughout your life as well, or no?
No, I try to stay here.
Steeler through and through.
Yes, that's
Or
it.
Penguin. What's your favorite sport?
That's hard to choose. I like them both.
Okay, fair enough. And your career before you joined the Breakthrough Institute, which is, I'll have you tell the whole group about it, but you were an engineer first?
Yeah, I started out as a design engineer working at Siemens and Westinghouse power generation, originally on the non-nuclear side, the balance of plant, turbines, generators, all kinds of crazy robots to go in and fix things. So you don't have to take the whole generator apart, for instance. It was a lot of fun. But then I spun out into consulting instead, because at some point I wanted to do a project that was great. My boss didn't think it added value, so I left and
What project?
Sold it back to their boss.
Awesome. What project?
It was a project to help remove the wiring essentially from a generator in a much shorter amount of time in the field instead of shipping it back to the factory.
And when you say generator, you're talking about the big electric box connected to a turbine?
Exactly, yes.
And is that just what I think it is, a bunch of coils of copper wound up or something?
Yes, but the coils of copper 3 inches wide by 7 inches high instead of what you think of in like a normal motor where it's just a spool of wire. Mm-hmm. They're very large. They're internally cooled with hydrogen or water. So same concept on a much, much bigger scale.
Yeah, amazing. How long do those things last, by the way?
Oh, most of them are original to their plants.
Amazing. And what is the mode of degradation? When a generator fails, why does it fail?
It's usually a failure in the insulation around the wiring that then arcs to the stator, which is generally just iron plating. And then depending on how strong the current was at that time and how badly it failed, you can melt the end off of the whole generator, or you could just have to replace the wire.
And they're heavy, and that's why you invented the way to do it on site, right? Because it's
they're
a lot of metal.
Incredibly heavy. Yes, you're talking hundreds of tons for the base.
Wow. Yeah, and I guess it scales up with size too. So if it's like a 10 megawatt generator versus actually, how does it scale? If you had a 10 megawatt turbine versus a 100 megawatt turbine, how much bigger or how much heavier is the generator? Not 10 times.
No, it's not linear. It's basically an inverse exponent for rough calculation. So the largest can be an order of magnitude larger, but only twice the physical size.
Yeah. And that's probably holds true amongst a lot of electrical equipment in general.
Right. And that's also what is a benefit for, say, electric motors for cars, because they don't linearly increase with horsepower and torque of output, right? You can get a lot more out of a small package. Otherwise, EVs wouldn't work.
Great. Okay, so after you showed up your boss, what happened in the next part of your career?
I did a lot of consulting for various different companies. I did a stint where I worked for a high-end vacuum chamber manufacturer, uh, doing components and coating innovation that led to some of the components or chambers that currently grow industrial diamonds at low cost, or
Like
apply.
Diamond Foundry, that's one of the big. That's one of the companies that like pioneered that space, right?
Right. That is not the one that I worked with mostly, though, but it's the same general concept. I designed one of the first chambers that did that for a company. So
Cool.
I wasn't at the company that was growing the diamonds, but I designed the vacuum chamber that they used. Another thing was depositing newer materials that haven't been put onto wafers before effectively in different ways. It was very interesting and out of the power generation realm, but I got to do some new things.
So you're just like a generalist engineer, mechanical, I guess is what you call yourself, or no?
Yeah, I have degrees in mechanical and nuclear at that point.
Okay. Oh, so you have a degree in nuclear too.
Yeah.
Okay, cool. When did you study nuclear?
Same time as mechanical.
Oh, I see.
University of Pittsburgh has a dual program, and I actually was the first class to go through the nuclear side.
Cool. Cool. Um, okay, but it sounds like, yeah, you just take on a lot of interesting and unique projects. So I
That
guess,
happens a lot when you just branch out as a consultant for the first time. You take a lot of crazy projects, but it also is fun because you get to work on different things instead of working on the exact same thing every day.
I think it's a ton of fun. How do you build a book of business though? Like, how do people know to go to you, or like when you're available? That's like what I imagine is hard about the consulting life. It's like the clients might come, but you might be on another project. And then like when you have extra time, how do you make sure you've got clients?
Yeah, that is tricky. It doesn't always work out for everybody. I was fortunate that I was able to navigate that fairly well. Um, but sometimes you could have long lulls, and you try to fill that with long-term projects that you can work on in pieces as the shorter term projects get completed.
Is it stressful?
Yeah, but it also is rewarding with the fun of variety. So
Yeah, exactly.
you get both.
Yeah,
You
yeah,
can't have one without the other.
yeah, yeah. Any other projects that you did as a consultant that you want to highlight?
Oh, I worked at Insaldo for a while, which used to be Union Switch and Signal for railways, doing railway safety programming. Basically did control systems that were safety reliant or safety dependent, that had to fail safe. They were some of the first to pioneer trying to crash programmable field gate arrays, which are now very important in the digital INC space for nuclear.
Mm.
And so I worked on that when it was very young. I wouldn't say I'm the expert on them now, but I know that you can make those very cybersecurity safe and fail safe because of some of the work I previously worked on.
And what is the state of digital INC, digital instrumentation and control for nuclear?
Well, there's currently one digital room, which is a university reactor, but a lot of existing plants have moved to digital readouts and controls to some extent without fully digitizing the entire control system. New reactors are largely going full digital wherever possible. That obviously comes with more cybersecurity concerns. Old analog systems, you'd have to tap directly into the wire of the control system. Digital, there has to be some communication back and forth. And if you can interrupt that communication, then that's a challenge. But
And why is it? I never understood the cybersecurity qualms about digital INC. Why don't they just set it up such that it's not connected to the outside world for like the critical control pathways, and like you can still have it like hardwired to a specific control room
yeah,
for certain commands, right? So like what's all the hesitation?
the big hesitation is a lot of developers have said they don't want to hardwire it to a room on the site. They want to monitor it remotely.
Mm-hmm.
And if you're monitoring remotely and controlling remotely,
Mm.
then you need to be able to send signals into the plant, and it can't be air gapped at that point.
And why not just have one-way communication? You can remotely monitor, but if you want to make a maneuver, you got to send someone into a room. Isn't that a good compromise?
Potentially, and some are looking at doing exactly that. But if you want a design where you actually have nobody on site, say just a small microreactor that's out in the middle of nowhere,
Yeah.
then you wouldn't have somebody there to enact that change. And you also have to have real-time communication with that person from the control room that's monitoring it potentially far away. And so you need to have additional redundancy there. These aren't things that can't be overcome, but there are things that are still not totally defined yet.
Yeah. I heard, I forgot which utility it was, but like I remember Duke saying that they spent like $300 million at one point trying to get a digital INC implemented on a power plant. And I don't know what the result of that was, but I think I remember that number, $300 million to implement digital controls, which just seems so astronomical to me.
Well, I haven't heard that number, but at some point, some plants have had to replace a lot of control systems just because they're getting old, they get degraded.
Yeah.
And at that point, you have to think, do I want to just replace it with the analog? Or do I want to try to go to digital? And what are the benefits be of each? They might have had a situation where they were going to have to pay $300 million one way or the other. And so which way did they want to go?
Well, that's an interesting look at it. Okay, cool. Oh, sorry, we went on a little tangent there with INC. Any other projects? Any other projects you want to bring up before we get to your work at Breakthrough?
I've done a lot of background analysis for either research for, say, EPRI or consulting analysis for some of the advanced reactor developers. I can't really talk about which or what I did because of NDAs, but every one of those projects was a whole lot of fun. And I feel that I helped move some of those things forward for those companies.
And do you still take on like technical work, or have you switched gears to policy?
We do some technical analysis at Breakthrough, but most of it's policy at this
What
point.
about you personally? Have you
I don't
hung up
do
your
extra,
technical engineer hat or no?
I don't do technical consulting at this point because of how we have things structured at Breakthrough.
But do you miss it? Do you?
I do.
Yeah, I bet like you itch for a project here and there.
I do. Yes. It's difficult when you've been in the design consulting space for so long to just step out of it. But
Yeah.
I feel like this is where effort was really needed to move the whole industry forward. And so that's why I'm working on it.
No, I'm so like once again, like reading your work and just seeing the level of understanding and specificity. Like I'm so grateful that someone like you is in the policy or in the, I don't know, what do you call it? Do you call it policy sector, advocacy sector? What exactly do you call your effort of communication?
Research and policy is really the way I think about it because it's fundamentally research fact-based, but we apply that research to policy.
Yeah. Okay. How did you get introduced to Breakthrough initially?
Well, I've read their work for years. I'm also friends with Jessica Lovering, who used to be at Breakthrough.
Oh,
and so that was an easy
former
connection.
Titan. Yeah.
Yes. So that was an easy connection to make.
Great. And remind the audience what is Breakthrough's motto or theme or mission?
Technological solutions to solve environmental and societal problems.
And what percentage of their work focuses on nuclear?
At this point, we have 3 main programs. So you could say a third. The nuclear energy program is more applied than the other programs, which are a little bit more fundamental research based. But realistically, there's 3 kind of pillars that we work on.
What are the other 2?
Overall, a higher level energy and climate program.
Mm-hmm.
And you would think that nuclear would just be part of that. But because our work is very applied and we have different approaches to our research, we're a separate department, essentially.
And what's the other one? You said there were 3.
Agriculture.
Agriculture. Oh, cool. Yeah, that's good. Yeah, I love. Yeah, I think your organization looks at problems the right way and looks at the right problems. So I'm like always very happy to
Thank you.
come across your work. Yeah. Um, how do you decide what to focus on within the nuclear realm, and how does that change over time?
Strategy. So when I started this, I said the thing that is missing from everywhere is direct contact with the NRC. So the first point of strategy was go to every NRC meeting, every single one. Sometimes I was in 3 at once, and be the voice for the public in the room to not only convey to the NRC what's important, but to also hear all the information, be able to connect the dots between different rulemakings, different proceedings. After that, we expanded out to make sure that we're commenting on all of the relevant proceedings very formally, presenting to the NRC at meetings instead of just listening and commenting at the end, and higher. Since then, we've moved on to talking to the commissioners directly, to members of Congress directly, and thinking about how not only what the NRC needs to be successful, but what might need to change to enable them to even make those shifts that everybody wants them to, because they are constrained in some ways of what they can and can't do by law. And so some barriers need to be addressed in order for them to make the shifts that a lot of people say they need to make.
What do you think they need to make?
I think the number one shift they need to make is to consider the cost and benefits to the public as a whole, not just the on-site costs and benefits of the plant. So not just the risk provided by the plant, but the counterfactual risk of what the plant would be reducing in terms of risk already prevalent in the environment, for instance, from alternative energy sources.
So everything from climate to air pollution to any other waste stream that any other energy facility might dump or something like that.
Absolutely. And that is actually the top line of what the commission previously said is their safety goals, is nuclear should be as safe or safer than alternative energy sources. But that is the only place they actually consider or even say they want to consider alternative energy sources. So we want them to actually do that math.
Okay, so is the barrier towards enacting that cost benefit analysis cultural, institutional, or legal?
Yes.
Okay. Do you have a different strategy for each?
Yes, we do actually. Cultural is, or institutional culture is the most challenging. The NRC has been operating the way it is for a long time, and getting them to realize that they need to consider these other aspects is going to take time. But it needs to be consistent engagement to ever make that happen. Yeah. You're not going to get that consistent engagement unless there's a group like ours that shows up to everything. Cultural, there are diverse cultural views in the public about nuclear energy in general, but there's not necessarily a large group of people that oppose nuclear strongly. And there are definitely areas in the country that embrace nuclear energy. So it's not a matter of changing everybody's mind. Nuclear doesn't have to be installed everywhere in the country.
Totally. Or
should it be? I mean, we don't want to cover every square foot of the country with anything.
Yes.
Right? So that is a barrier, but that's something that we're taking care of through a separate effort called Build Nuclear Now.
Yeah, awesome.
And the third is legally. In the Atomic Energy Act, in the Energy Reorganization Act, the NRC is directed or mandated to consider the general welfare of the public, not just the health and safety of the public, energy security, the national interest, things like that. In their licensing decisions, they only consider the health and safety of the public, or I should say a reasonable assurance of adequate protection of the health and safety of the public, which is important. It's not absolute health and safety, it's reasonable, adequate protection and protection of the environment. That doesn't consider things like the national interest, the general welfare of the public, which includes things other than just the impact of the plane itself, and on. Other regulators, safety regulators, do consider off-site benefits, not just on-site costs. Otherwise, the FDA would never approve a drug that has any side effects, for instance.
We wouldn't have antibiotics because some people are allergic to them. Yeah.
Right, exactly. So getting the NRC to follow that mandate more explicitly will probably, at this point, because it's so ingrained in their institutional beliefs that they aren't mandated to do that, is more direct, clearer mandate from Congress to clarify.
Okay, so you're saying that the legal framework is actually pretty much already where we need it to be, but there needs to be some sort of, I wouldn't say political pressure, because I don't want to say political from like one side of a political party versus another side, but there needs to be some sort of government pressure to actually follow the rules that are in writing.
Yes. The difference is the Energy Reorganization Act has split the Atomic Energy Commission in two. And one line says the Nuclear Regulatory Commission will be responsible for regulation of this. And they took that as they do just safety regulation, not that they took regulation in context of all the other things of that act. Mm-hmm. That's the component that needs to be clarified.
Yeah. And wasn't it already haven't there been congressional attempts to not only clarify, and I'm kind of leading into your article here, or but Congress has taken action, like bipartisan, to tell the NRC to streamline licensing. Isn't that right?
The Nuclear Energy Innovation and Modernization Act in 2019 directed the NRC to modernize a whole lot of things. The main component was to develop a framework for licensing advanced reactors, both fission and fusion, that is technology inclusive, which means can be applied to anything, risk informed, which means it focuses on the most important aspects to risk, not risk based, which means it has a strict number and you must meet this number, and performance based, which means you set performance objectives instead of prescribing what somebody must do. The example I usually use to explain this, because this is where most people get lost or their eyes glaze over, is if you imagine a car, prescriptive requirements are that it has to have four wheels. It has to have turn signals on each quarter, and they must be a certain height off of the ground. It must have an airbag on both sides. It must have brakes with a certain pressure of stopping, power on the rotor. If you have performance objectives instead, you say the car must be able to go straight down the road. You must be able to control it, stop in a certain distance. You can prescribe the objective distance for them to stop, but not necessarily clamping force on the rotor. You must be able to signal to other cars that you're going to turn, things like that. So you set objectives, and then the car manufacturer has the flexibility to design a car that meets those objectives. Then the NRC still would be able to say that whether or not those objectives have been met, but it's not a checkbox. You must do these prescribed things. That's what we currently have in licensing framework, is a checkbox of prescribed things that were all set in place for large light water reactors and don't apply to many of the new designs.
And if Congress told them to do this, why do we still have a problem?
Well, because that rulemaking effort hasn't gone very well. They were originally given until 2027 in the law, but then Congress said, do it faster, please. The commissioner said, okay, staff, do this faster. And the staff said, okay, we can do it faster, but we have to copy from the existing frameworks. And that's where the problem started, because it's not a fundamental change to be this performance-based at the core rule anymore. They're copying from what they already have that's prescriptive. From there, it kind of just got worse. They copied from LMP, which is the Licensing Modernization Project that the industry put forward as a way to risk inform the existing rule. So it's basically, think of it like a lens of how you can look at the risk existing rule in a performance-based way. It still doesn't fundamentally change the rule to be something simpler and more streamlined, to quote NEMA, for innovation and commercialization of advanced nuclear. That bar is important because it's not saying just make a framework that's technology inclusive. It's saying make one that actually allows for innovation and commercialization. So not just a rule, it has to be a good rule that does this. So they codified, or in this draft rule, this LMP. Well, industry doesn't need that. Why? They already have it for the existing framework. We don't need another version of it in a new rule. So industry and we gave them feedback on that, and they said, okay, we'll make a second sub-framework in this new rule that is largely just a copy of the existing rules without the modernization part of the LMP. So now you have two different frameworks in the same new rule, neither of which meet the spirit of NEMA. The staff says we've been responsive to feedback. We now have two rules, but the stakeholders, including Breakthrough Institute, feels that neither of these rules is what NEMA intended. And there shouldn't even be two different frameworks, because if you can envision two frameworks in the rule, you could envision 3 or 4 or 5 different approaches to this. What the rule should be is the high level performance objectives, requirements that they can maintain security and maintain oversight during operations, and these specific approaches of how to meet that, which are the current two frameworks, should be guidance, because guidance is, by definition, one way you can meet a regulation. And since you could easily meet it with these two frameworks, but you could envision other ways to meet it as well, all of those should be in guidance.
Yep. So, yeah. Okay, so that's pretty obvious. Or not, maybe it's not obvious, but very eloquently defined. So thank you. It's not happening though, is it? And what makes us think, if Congress already said, hey, get your act together, this is important, and after 4 years after that, we're still in a bit of a mess, what makes us think that anything anyone does can change anything?
The commission has a whole lot of discretion here. They haven't received this draft from the staff officially. They've been briefed on it, but they haven't actually seen the full rule package. When they do, they could say, go back and start from scratch. Or what we think they should do is say, these are the changes you need to make. Go back and fix this before we send it out for the formal rulemaking period. Because right now we're in an informal period that doesn't have to follow the Administrative Procedures Act. So there's a lot of flexibility. If they send it out for additional public comment, you enter that formal rulemaking, there's less flexibility. They'll also just get all the same public comments they've already received prior to this point. So we're kind of taking a step forward in the process. We're not taking a step forward in achieving the goal we want. So the commission could tell them to do anything at this point. The staff would have to consider what the commission tells them to do. That's the point at which we can get major changes.
And why can't we just get something super simple under our belt first? Like something I've never understood is, like, why does it take more than an afternoon? And I'm not kidding. I mean, literally an afternoon for a few smart people to get together in a room and say, our highest level performance standard, which will take place effective immediately, is the applicant has to sufficiently demonstrate that there's less than a 1% chance of death every gigawatt year of production, or something like that. I mean, I've just made up those numbers on the fly, but a few smart people who know enough about heavy industry and hazards and the electricity industry and comparable other standards across industries. Why can't it literally be that simple? It's sent in front of the commission that afternoon. The commission meets that afternoon and says, yes, this is like the most reasonable, simple thing. Any fourth grader can understand it. It's in line with other industries, and here's the proof. We passed this afternoon.
Well, there's some laws that govern that it can't go quite that fast because there's requirements for public comment periods and things like that. But in terms of making the decisions, we asked the NRC staff on multiple occasions to hold a workshop so we could not just comment on what they provided, but actually discuss it and come to some sort of agreement. and they declined to engage with us in a workshop. They actually said that it would be not legal, which we disagree with, because one, it's in the informal process now, so there's a lot of flexibility. Two, it's not as they said, a negotiated rulemaking. We weren't requesting a negotiated rulemaking. We just wanted to talk, and there's nothing preventing that. They hold workshops on other matters all the time. So they declined to do exactly what you're saying, essentially.
Yeah. But I guess my thinking is there's only so many people that need to be convinced. And as long as the argument is put together in a way where it doesn't require someone like go back to like a technical expert, where it's just like any adult can understand the basic argument and just like give us a starting point to sink our teeth into. Like, it seems to me that if it is as simple as just like make the performance criteria a one sentence thing that is totally in line with every other industry, just individually meet with every key stakeholder at the NRC and in Congress, over the course of 2 months, just line up one-on-one meetings with everyone, get everyone to say, yes, this makes sense. And then, like, why doesn't it just snap together?
The rule is going to be a little bit more complex than one sentence, but it should be way simpler, as you're suggesting. Definitely.
How did it get done in the AEC time, the Atomic Energy Commission? Before the NRC was created, let's say a plant wanted to file an application in 1968. My favorite plants, let's say Point Beach 1 and 2, started construction in 1968. How did they do it?
It was very different. There was a lot less regulation because regulations have been developed as things have been discovered in the industry, some of which make a lot of sense because safety issues were uncovered that we just weren't considering back in the Atomic Energy Commission timeline. But some of which have been added just in an abundance of caution of something that could go wrong. However, it was very deterministic, which the existing Part 50 still is deterministic. That means that the rule has determined that doing X means that ultimately, when everything's put together, there'll be enough safety. You're not actually calculating whether it would provide that. You're saying if you have multiple barriers to release, for instance, defense and depth, that's important to ultimately result in safety. You must have a backup safety cooling system. That's important. So it determines and then prescribes certain things must happen. That can be a very fast rule to license with, but it's not technology inclusive at all because you're determining this for a specific design. And BWRs and PWRs are so similar ultimately that the rules are basically would have been the same even if you looked at them separately. Not the same as like a sodium fast reactor.
Why, do you know what the origin story of the NRC was? I'm still confused why there is even a federal agency to regulate nuclear with such overwhelming powers, given that is there an equivalent agency for like a building, like a skyscraper? I mean, it's like if a skyscraper were to collapse, I mean, we saw this in Miami, like hundreds of people die. If a nuclear power plant melts down, 0 people die. So I don't understand why nuclear power plants are even in a higher hazard profile than a normal building. And we regulate the new building of like tens of thousands of buildings across the country every year that hold like hundreds of lives of public people's lives in peril every single day. And yet somehow they are able to figure it out without like regulatory malaise.
Well, that's not quite accurate. The scope of buildings is so large that this has largely been pushed down to the local level.
Yeah, why not that? I mean, Germany had a local regulatory bodies. Each state had their own nuclear regulatory body. Why won't we have that system here?
We do have that system. It's called agreement states.
Tell me about that. Yeah.
So states can choose to have an agreement with the NRC where they will regulate instead of the NRC regulating. They
A power reactor, like a gigawatt scale power reactor, could they do it?
They currently regulate material facilities like
But could
particle
they
accelerator.
could
or
they
medical
assert
facilities.
jurisdiction over a power reactor, a state?
The NRC could give them that.
Interesting.
They, I don't recall any of them having jurisdiction over power reactors right now.
But it's possible.
I believe so.
Would that be an interesting strategy for Breakthrough to advocate for? Create
No,
50 different experiments in legal reform?
no, I don't think so, because the application of, they have to meet the same or stricter regulations. That's part of the agreement to be an agreement state. But the way they do it, the processes they use are self-defined. And that could end up with 50 completely different ways you have to apply for a license, which could make it harder for somebody to build in multiple states.
But it's right now it's impossible for anyone to build one facility in any state ever.
Right.
Like Vogel will be the first gigawatt scale or first like power reactor that the NRC has ever seen a license from start to finish. So it seems to me like we're solving for the wrong problem. If we were able to create 50 different experiments of interpretation of how to meet those standards, one of them is going to break ahead of the rest in terms of like culturally being able to like figure this out. And then like, okay, every single state could have like several gigawatts of new nuclear capacity added. Like that's a lot of business that a company can focus on in that one state and then find the next state that's willing to have some sort of reciprocity, like while you're building your first gigawatt scale or any scale reactor.
It's an interesting idea, and you could have a state that really moves fast on that and builds expertise, but they would have to build a lot of internal expertise to be able to do something like a large power reactor. And second, it's not always successful, because you can look at California with, say, their CARB standards that are different from the rest of the nation. You could say that they broke away from the pack. Nobody else followed them.
Right, but they broke away from the rest of the pack to make things more restrictive, right? In a certain sense. What I'm talking about is break away from the pack to make things easier. And you only need one to do it and show how it works for it to totally revolutionize how we do nuclear licensing in this country. Because then you've got a real proof point. Then Alaska could say, oh, Texas did it. Let's copy we'll hire similar people. We'll, culturally learn from them. And then it just spreads like wildfire. And all of a sudden you've got 3 gigawatts going up in Texas, 2 gigawatts going up in Alaska, 15 gigawatts going up, along the border of Tennessee to every neighboring state. It's like, why not?
Well, you can do significant process innovation. You can have things that are more streamlined in how they're run through the regulations, but part of the agreement is that you still meet the requirements of the NRC regulation. So the route is still there.
But what are those requirements that are so hard to meet? Like I still to my bones and me doing like thousands of Titans of Nuclear like interviews, 500 published, thousands, offline. No one to this day, after 5 years of doing this, can explain to me how if we've been able to melt down 4 gigawatt scale cores, 3 Mile Island, Fukushima 1, Fukushima 2, Fukushima 3, and not result in a single death. Like, why is it not the easiest possible thing to meet any sort of regulatory standards? Like, why aren't the regulatory standards as simple as show us how you don't kill anyone if you melt down? Like, which is so obviously, like the empirical evidence shows us, no one dies when there's a meltdown.
Well, that's exactly what the NRC asked an applicant to do. Show us that you're not going to kill anybody when this melts down. But they take each separate application as starting from square one, with no context of these other things didn't have any impact.
But couldn't a state do that more efficiently? I mean, and what I'm thinking is literally whatever the building regulators do in a state, put a civil engineer in a room, a mechanical engineer, like look at the basics of the system, look at the decay energy, like any mechanical engineer can understand heat and material science, and just show, it's not enough radioactive material that won't go far enough to hurt anyone within this distance. It's just simply not enough source term.
Yeah, that's exactly what I want the NRC to do broadly. Can a state do that differently? In some senses, yes, but the rub here is that even if you had a microreactor, for instance, that was so safe that you had a full meltdown and nothing got out, complete containment of source term, right? You still have all these other regulations that are already on the books that you have to show that you comply with or seek exemptions to, even if they're irrelevant to safety.
Yeah, but okay, so that's my point. What I was thinking is a state could just make the exemption process easier, because like right now I can understand how the NRC could look at those exemptions and make you prove each one to the utmost extent, charge millions of dollars for every one of 9,999 exemptions. But at the state level, you could potentially submit your application, give the highest level stuff. Hey, you know, this is not going to hurt anyone in any circumstance. We all agree. Okay, we all agree. We all agree. All right, we all agree. And then say, here are 9,999 exemptions that I'd like you guys to complete in 1 month. Given that we all agree, there's no realistic possibility this could hurt anyone. And then they've done that. They've complied with the big rule book through an exemption process at the state level.
The NRC could just do that just as easily too.
But I struggle to see how you could overcome the cultural inertia and the institutional inertia of the NRC to get there. Whereas with a state, you can start from tabula rasa, is my thinking.
Yeah, that is true. That's absolutely true, and that's why we talked about inertia, cultural inertia, earlier in this. It is definitely a unique problem at the NRC, and honestly, most other large federal agencies, they have a hard time turning the ship quickly.
Totally.
Even if they think it needs turned.
Exactly, because it's like I visited them, and there was like Christine Savinicki was the chairperson of the board. Margie Doan was the executive director. Honey was in charge of nuclear reactors. I met with each one of them. I'm like, oh my God, they totally get it. Like they want this reform. Like I had hour-long conversations with each. They like understood. They're like, oh yeah, we're gonna try to change things, and we think that makes total sense. But like it had the people at all the right points of leadership, and then nothing.
Yes.
So I guess that's why I'm advocating for alternate strategies, just simply because I'm sorry that I got on my soapbox here. I'm really
well, you might get your wish with fusion. A lot of fusion companies are looking specifically to states because agreement states already operate under Part 30, which is non-critical, non-special nuclear materials and particle accelerators. And so if fusion is allowed to fit into that slot of regulation, then there are several states that are already waiting to license them.
Yeah, I hope so. But I think, man, with fusion, it's like once they find out how many neutrons are shooting out of that thing, I think they're going to be in for a world of pain. I think they're going to go through everything the fission industry went through and more.
Well, we're writing something about that right now.
Oh, I can't wait to read. No, I have to say it again. It's like your guys' writing is just so good. Like I'm so excited now to see when your articles come out. Because you just like get so straight to the point and give an analysis that I think without just like your like so deep fundamental understanding of the circumstance, you wouldn't be able to present. So I definitely encourage everyone listening, like go read your articles.
One of our recent articles highlights part of the challenge with why you can't just do XYZ. And that is the alternative evaluation for risk insights. That's part of the new Part 53 framework. It is supposed to allow a reactor that would have very low offsite consequences in the event of a maximum accident to not have to do a probabilistic risk assessment, or a PRA, which is where you build the safety case of everything that could go wrong, how likely that thing is to fail, and what sequences go on from that failure. PRAs are used now for Part 52 applications to confirm as like a second check. They're not required currently in Part 50, but probably will be in the future. But Part 53 currently requires PRAs regardless of the framework. ARI, as it's shortened, was supposed to eliminate that requirement for reactors that are safe enough that would have low dose in the event of a maximum accident. The problem is some of the requirements in that are literally impossible.
Yeah, tell me more about that. Okay, this is a great part of the article. So yeah, why don't you say it out loud?
They are quite literally impossible. It assumes to eliminate the need to justify any frequency in using a PRA. They basically asked not what would be safe enough that we could avoid using PRA. They asked themselves, how do we eliminate the need for a probability, a number of how frequently this could happen that you would get as a result of a PRA. And so they said, we're just going to assume that it happens every year. Problem with that is it's physically impossible to fail your core in a maximum way, rebuild the plant, have it fail again the next year, and on and on and on for the whole license.
Yeah.
Nor is it possible for it's possible, but it's not going to happen. The NRC isn't going to approve restart within a year, like in that timeline, even if they wanted to. And they wouldn't approve restart every year if you fail your core 40 years in a row.
Yeah.
They also calculate the dose based on people receiving a dose across 50 total years. You have the initial dose at the accident time, and then very small latent dose over 50 years that adds up. Problem with that is, even if you were 1 year old or just born when the first accident happens, only 30% of the population alive at that time would even be alive for the 50th year. And then when you think about them happening for 40 years, nobody would be alive from the very first accident to the, about 1% of the people maybe to the 90th year after you get the full 50-year latent dose. And so if assumptions are not bounded in physical constraints, then they're not fundamentally protecting the health of the public. And they're not something that a licensee, even if they held a license, could prove they're complying with.
Yeah. So yeah, it's so wild. So, and since you brought up dose, what's your perspective on this? Because I've wavered back and forth. How important is going after the dose targets themselves? If you were able to just simply increase the maximum dose target to something super reasonable, like 100 millisieverts acute dose, which no one has ever actually suffered any injury from, and probably 10,000 times higher than what the dose standards are right now, how much would that alleviate some of these regulatory requirement issues?
It would alleviate them a decent amount, actually. For instance, ARI assumed that over this 50-year period, you would get 25 total REM, 3 of which would be in the first year. So you have a 2 REM dose from the actual accident, or 1 REM dose in the first 24 hours and 2 REM over the rest of that first year. That's higher than you would ever expect from an actual accident anyway. So do I think the dose limit should be higher than that? Yeah, to actually show effects. And I can talk about why that wouldn't even show cancer effects as well if you want. But just limiting to that, which is what emergency planning guidelines are for FEMA already, just to keep it in line with that, not fight battles at FEMA as well, that would simplify things. ARI had some fundamental basis in improving things. It's just the entry conditions were impossible. So we can fix those, then doing a dose-based metric is useful.
And how much of the problem, I mean, this is a little bit of my own thesis here, like how much of the problem comes from the nuclear industry itself? If I were to look around at the nuclear industry and where every single dollar comes from, including the next gen nuclears, it seems that almost every dollar comes from increasing the safety standards, not decreasing them. Like you don't need like especially like all the new reactors that claim some sort of like higher safety theory by not being able to melt or whatever it is. If you were to use reasonable dose requirements, they wouldn't, like, nobody would need their technology. And like, and all of the other nuclear businesses that like upgrade existing plants, provide services, everything from decom to security, none of these businesses would exist. So how much of this is like the nuclear incumbents and like the nuclear elite, like whether explicitly or just implicitly or through inaction, effectively lobbying for higher regulations?
Yeah, that's an interesting question that I don't have a number to put on. There's a lot of companies that do that kind of service work that are dependent on it. Some of the developers, however, have no ties to that at all. They're not from the traditional industry at all. Their backing is not from the traditional industry. And so they're focused on the product that they think will meet the regulations and provide value to the grid.
But their defensibility is like, oh, we produce less waste, or we are quote unquote safer. Like that's their entire pitch. Like I feel like a lot of the new developers would not have a business if safety wasn't like as, emphasized in the industry.
Yeah, that is an interesting question. Would a developer that uses TRISO fuel even try to use TRISO fuel if standard light water fuel was considered safe enough? And it is safe, but the fact that it can melt down in a reactor and the TRISO won't melt down in a reactor does make it fundamentally safer, but is that needed? That's an interesting and important question. Not one that we've tried to put a number on because it would be really hard to actually quantify.
Yeah, but I feel like I'm not accusing anyone of doing this intentionally. I think unintentionally they do it. Every single time the TRISO people say we are meltdown proof, they are scaring the living shit out of everyone about the entire industry itself, because they are reinforcing that underlying notion that a meltdown is a disproportionate hazard that must be avoided. Whereas if instead they downplayed it, or like a thriving industry would have downplayed this, they would have been like, no one died. Natural gas blew up this other guy's house and blew his whole family into pieces the other day. What are you worried about? Like that's how a normal industry would operate if they weren't like feeding off of their own demise.
Yeah, that definitely occurs sometimes. Absolutely. And some utilities, especially utilities that are considering nuclear for the first time and are really worried about the potential PR or just loss of investors if they are a public utility, wants basically assurance that there won't be any impact to the public like that, and will only consider designs that can say that they won't.
That's interesting.
So there's some market drive to developers to do this.
Yeah, I see what you're saying. That is interesting. Great. Well, we're running low on time, but I definitely want to pick this conversation back up. If you want to talk about like dose sometimes, you mentioned that you had more to say on that. We could do a whole episode on that too sometime if that's something you want to speak to.
Yeah, I wrote a white paper on that too that I'd be happy to talk about, because I think that's something that isn't discussed from the lens that I put on it enough.
Yep. Adam, anything else you want to leave our audience with right now?
Oh, we covered so much.
There's so much more to cover.
There is opportunity to fix some things at the NRC. They are working on some important rulemakings to try to do that, but some of those rulemakings are stalled. We need to get them across the finish line. So there is opportunity for optimism. We need to make that opportunity a reality, and that's basically what we're working on right now at Breakthrough.
Awesome. Adam Stein, thank you so much for your writing, for spending time with us today, and for your future work to come. So excited, and let's talk again soon.
Thank you.
And initiate at least a new approach to the many difficult problems that must be solved in both private and public conversation if the world is to shake off the inertia imposed by fear and is to make positive progress toward peace.